Hi, Algebra 1. This is the review I handed out. This will be for our quiz that we have on Wednesday. First thing before I do too much to this problem, I'm going to figure out all the different points. So I have a point there. It looks like it's -8 and 9. Then I have a point there, which appears to be -4, 5. I have a point there that appears to be -1, 5. And then maybe pick that point. That looks like 0, 0, doesn't it? And I have a low point down here, which is 2, -4. And this one has a little bit of a turn. So that's going to be like 4, 0. And then this point up here is going to be 8, 6. And then we have an end point down here of 9, 0. So now that I have all that, I can kind of get into this problem. So write the domain of the function. So what's my furthest left x value? It's my furthest left x value. Yeah, it's -8. What's my furthest right x value? That's 9. So I'm going to use the hard brackets because they're points. So that's our domain. Identify the minimum. The minimum is going to be the lowest y value. So that's going to be our minimum. So our minimum is going to be -4. My maximum will be my highest y value, which will be 9. And then I can do my range. My range is going to go from my minimum to my maximum in the y direction. And you're going to put hard brackets because those are points as well. Identify the coordinates of the y-intercept. Well, the y-intercept appears to be at 0, 0, because that takes place right there. Coordinates of the x-intercept, so it happens here and here. So you have 0, 0 and 4, 0. There's two different places. The interval that is increasing appears to go right here. This is all increasing here. So remember, we're going to use the x values to describe that. So it's going to go from 2 to 8. And these will be parentheses. That's not a point. That's not a point. It's the region. Then we're going to take a look at the point that it's decreasing. So decreasing, it decreases here, and it decreases here, and it decreases here. So there's 3 different regions that we have to list. So using the x values to describe it, so from -8 to -4 is the first region, that's right here. And then from -1 to +2, that's this next region here. And then from 8 to 9. Identify where it is constant. Well, constant means it's a horizontal line. It's right there. That's horizontal right there. So I use my x values to describe that. So from -4 to -1. Again, these are the regions where it's either increasing, decreasing, or constant. If you have any questions, make sure you ask me. All right, so f at 5, so f at -5. See this -5 here? So I'm going to find the -5 here. I'm going to go straight up. So what does that appear to be? That appears to be +2. And then if I go and I want to find f at 1, 1 is right here. So I'm going to go straight up. It goes right there. That looks like it's 1, 2, 3. That looks like it's 4 in the y direction. And then when I want to get to writing more of this, let's see. I'm going to find -3. So I'm going to look at -3 in the x or the y direction. So that's down here. This is -3 right here. So you're going to come straight over. So I got -1, -2, -3, -4, -5, -6, -7, -8. So the x value is -8. And then when I want to get to the and I want to get to the 5. So I'm getting right up there. So that's 5 right here. So that comes straight across. And that appears to be an x value of 10. So it's pretty easy to read. So on the back side, it says Mason is keeping track of the distance he walked after school one day. He walked at a constant rate of 275 feet per minute. His distance traveled can be modeled mathematically with d at t equals 275t, where t is the time in minutes. So if we want to find d at 30, it means I'm going to take 30 and plug it in for t. So I'm going to go 275 times 30. So 275 times 30 is 8,250. And what does it mean in the situation? So at 30 minutes, Mason walks 8,250 feet. Okay, what would it mean if d at t is equal to 5,500? So I'm going to replace this with 5,500 and then solve it. So 5,500 equals 275t. I need to divide both sides by 275, so 5,500 divided by 275. So t equals 20. So at 20 minutes, Mason walks 5,500 feet. Okay. So down below it says, in this situation, for the rest of these problems, I think this should be the rest of it. No, there's a couple more. That should be good. You are trying to decide if you want to take an Uber or a Lyft. You have studied the local costs and you've created the following graphs for the given. So Uber, so let's just highlight this. Uber is this one. Okay. And then Lyft is going to be this one. Okay, so Lyft will be the pink one. Okay, so just so we can see it, I'm going to get rid of those though. I don't want to see those. It's just too much distraction. So just giving you some perspective on what our graph has. All right. So the first thing is we want to go to x equals 3. So this is the 3 right here. So if I come straight up at 3, it says that they're equal. Well, I have one that's here and I have a little bit above that. So I disagree. And the reason I disagree is looks like the Lyft would be 11, where the Uber would equal 12. Okay, those are your costs. Then we want the Uber is greater than the Lyft. So you're talking about a portion of the graph which is above. So this portion right here is above the graph. So they're saying at 2. Well, that's where they cross. Is Uber above that line? I agree. You can say that the Uber is above the LX after 2. Okay. And then they tell us that Uber costs less for short trips that are less than 2 miles. So here's my 2 miles. So less than. So Uber appears to be less. I agree. You can say that the U at X is under L at X to the left of 2. Okay, then we have a trip of 5 miles will cost $15 on Lyft. So a trip of 5 miles, so here's 5. We're looking at Lyft, right? Well, does that appear to be 15? I agree. So you can do that. Then Uber costs more per mile than Lyft. I disagree. There's when less than 2 miles, Lyft is cheaper. Okay, and then after the 2 miles, it's more expensive. Then 21, sketch a graph with these features. We have 2 intervals where it's increasing. Okay, so two intervals where it's increasing. The function has two intervals and where it's decreasing. The domain goes from -7. Okay, so let's take care of that first. So I'm going to make this really thin. So 7, -7 is here. And then the 8 is way over here. Okay, so I want to make my graph in between them. We want to have a minimum of -5. So that means that I don't want to go below -5. And we have a maximum value of 9. Maximum value of 9, so that's up here. Okay, so inside that box is where I want to make my graph. Okay, so you want a maximum value and a minimum value, so we're going to touch those. Okay, so the function has an interval where it's increasing. So maybe we can say it's increasing from here to here, and then from here way up to here. They're increasing those two things. And then it's decreasing, so maybe make it like that, and then bring that all the way down. And there's a perfect situation. That's not the only correct graph, but that's how I would justify doing that problem. So if you can do this, make sure you ask me any questions you have on the homework. Other than that, have a